Alright, class. Can you go online and check now? Can you go and see streaming if it's live? Also, now we're gonna talk about linked list. Okay. Oh yes. Screen setting.
On the bottom left where you see scene, you should be able to just add a new scene.
Yeah, that's right.
Desktop capture. Or sorry, on the right where it says sources.
Is there window capture?
Window or display. So I guess just do display capture.
Yeah, because this is you can select. It's only do notepad now.
Oh yeah, it's up there.
Where? Here. There you go. There you go. Alright, so we should be ready, right? Okay. Now you see my screen. So CSC202. So linked list. Linked list. Can you make sure go on YouTube and see you can hear too?
Yes.
You can hear too, right?
Yeah.
Alright. So we just create a node, right? We want to make a linked list. So we need, this is with Java, so we create a node class with elements with the pointer we call next. And this is constructor, right? When you create a new node, we just set elements. Like this one, technically, you can leave it empty by default, no, right? So now we're going to create a list. So the first one, pretty much we want to do the add something to the list. So, but we said linked list has head and tail, so we need to create head and tail, right? So head and tail pretty much is the attributes, correct, of the class. So we call head. So what's the type of head? Node, right? Because pointing to node, right? And this is a generic, so we're gonna do E. So head. And we're gonna have the same thing with tail, right? So we have the head, tail, and we should have the constructor for the linked list itself when it is created. So when the linked list is created, you just pretty much just have head and tail to know, right? Because it's an empty list, correct? Okay, and now we want to start to add. So linked list has, remember if we were talking about an interface list that we've been talking about, let's look back into, it should implement, right, in your textbook. So we were talking about list interface. If you go back, this is an array that we looked at last time, but we were talking about list interface. The list interface should have, they call my list here, add, so on, which when you implement, you technically want to do the same, right? We want to create a list interface, and then you just switch to an interface here. Okay, my list. Like normally when I do interface, I like to I, and then I just say I list, like interface for list. I just represent an interface. So if we want to do the same, like in the textbook, it just implements iterator, right? And iterator is pretty much just from the Java, and you could do the generics too, right? Like use E. Okay, let's use E. Now make it, you need to implement the add and implement interfaces, right? Right, because yeah, this is an interface. Implement is for the class. Extends the iterator. Alright. So the iterator has one method named what? Iterator. Now this one should have that, and also you want to add, right? So this is public. So what I'm going to do, I'm going to make it like that. Let me see. So plus is public. Add. And this is E, the elements that we want to add. And the type is void. So this is the first one. And this is when we have an index, right? So in index. And E. Clear. And contains. So that's how you translate from UML diagram to Java code too, right? Contain, we have boolean. Contains E. Get pretty much just return an E, and you specify the index. So index of just provide the elements and return int location of index of E, and then is empty, pretty much just boolean, right? True or false. Last index of. So this pretty much just going to return like the last index of the list, right? And remove, we can remove item from the read list. So remove, after you remove, just say true if the list, the element is existing in the list, so it's true. Otherwise we cannot remove, return false. There's no such element to remove. Size, just return the size of the list. And we have another remove by index. So we provide index. And then it's going to remove at that location. And last one is the set. So we could set at specify index, and now this remove will return elements that we remove. And when we set, we pretty much just provide the location in the index where you want to set with a new element. And we could return the elements that we're replacing to, right, the old element back. Now the question also says, someone said remove, should it be void? It could, if you don't want to. If what happens if I remove something that's not existing in the list? If it's not returning, you could pretty much just do try catch and do exception, notify user, which you could just say, okay, true if we can remove, false if it cannot remove, right? So that's another way. It just depends on the design. Now,
does linked list have indexes? Do they have indexes?
array has index. We know by index, right? Location where it is.
Yes. I think they should have indexes too.
It depends on your design. If you want to add an index to it, that's why we're gonna see how we're gonna add index to the linked list, right? Technically, if you look at it, there's no index because it's just connecting by pointers, right?
And that's what's good about linked list, because it's connected by pointers. If you put it by index, it's just basically like a array list.
Yeah, we gotta see. We could implement with the index, okay, if we want to. Yeah, we're gonna look at that. So now come back to. So this one has another class that's implement. This is the array, right? We will talk about that last class, right? Now this one we want to talk about linked list implements iList, right? When we implement, we require to implement the methods, right? That we just create on the list, correct? And they are all right? So we want to look at add. Okay. Look at add. How do we add? So that's why they were looking at an image, right? So they were looking at image. We said first time the head and tail is pointing to the same location is empty, which is null. Now we want to put something, right? Like node, create a new node. And this node is going to point to another node, right? So there's a pointer. And then pointer at this point, it should point to what? If we have the first one, it's going to be null. And where is the head and tail? So first time is null, right? We already set to null, right? But now when I add a new one, we talk about add. The pointer of head and tail should point to the same location, correct? I will call head and tail. So how do we implement that? That's pretty much the question here. Alright, who wants to do that? He actually answered the question in Nesmo and remind me your name? Yeah, Andrew. He already answered how to add already. Right? You were talking about we have to link and we have to move the tail. V? We want to get a score. Maybe we should set up a game here.
What's the question though?
Student against professor.
Yeah.
Right? So now I have 50. I have 100 points. If you want to try to get the points from me, you have to play against me.
That's a little unfair.
Huh?
That's a little unfair. You can't make the rules and play the game.
We should get A's if we beat you. We should all get A's.
Okay, you add the rule now. Let's say if you put a statement right, you get a point.
Isn't node,
And then I subtract a point from me, right?
Professor?
If you get it wrong, I get a point back from you. Alright, let's start.
Node temp equals new node.
Okay, you want to try?
Yeah. And then
Alright, he said
after that,
node
node temp equals new node.
temp equals to new node. So how many points you want to bet?
I'll get a point.
A point, okay.
Point. There's an error. Well, the object.
What do you do?
Shouldn't you cast the object to E and then pass it?
Should we cast? Oh, we just do E. Actually, this is your then. You should type. Come on, type.
So what's the other node
You know, in your test, it's going to be just like this. An empty interface like that. You have to write a code in here. So this is just like your test, right? Pretend that it's coming in 2 weeks, so you should go back and review by doing this on your own.
Just go back to the node that you called the structure for the node.
Isn't it just
So you call new node, yeah, because we don't have an empty constructor for you, right? You have to pass in what element, right? Now the problem is your list. Let's see, is it correct? It says override. Method doesn't override method from its superclass. Public void add e. We call e here, right? And then we have to add e. Okay. So why it's not all right? The object, I think we have to do e here, right? I don't. That's why it says add the object. So technically, we want to do this again. Then it's just gonna add e instead of object, right? Then we don't have to cast, correct? Missing. Expected.
Implement is spelled wrong. Spread the E.
Let's just change those object to E, right? To cast. Node temp equals to new node E. So when we did that, technically we have this image, right? Correct? Is it true? Are we still missing something? What is it? Next should be equals to null, right? When you create new node, next should be equals to null, right? Like I said, like this should be by default, or you could just put it if you want to see null here, right? So it's pretty much just that one is complete, right? And then we still have problem with what? We, do you see it, we? Huh? Right? Head and tail was a problem. How do we fix it to this image? When we add, we want this image, right? But this one, head and tail still no. So we got an image. Are we done with the add?
I gotta get some points for that, right? Yes, me and him.
You get a point when you do it without help.
I didn't need help. He took over.
Alright, why don't you do the next one? Because it's not done actually. S still not
Next
done.
method.
Put more bets then.
He has some lifeline. He's not impressed.
Huh?
He has a lifeline. He's not impressed.
Okay, finish it then. You didn't finish it yet. Think about this. Think about.
So you need to check if, at the beginning, if the head is null. If it is null, then you do that. If it's not, then
Why we have to check?
because what if there's already elements in there already?
Right? Then the way you create is different, right?
Yeah.
And how do you know that pretty much you're talking about is empty? How do we check it's empty? Because you're going to say if it's empty, he said if it's empty is true, what do you want to do? When it's empty is false, what do you want to do? Like if it's empty, you say you want to do this, correct? If it's empty, you want to do this, right? And how do we check it's empty? Let's implement it's empty.
Maybe if count equals 0,
Count? Do we have count in here?
you can make a private int count at the top. Private int count.
Now you talk about how to implement size. If you want to say that.
Yeah, so size is like every time you add stuff, you just increment plus.
Okay, so you want to create a count. Okay. If you want to create a count, we create a count.
Equals 0.
Okay.
You wanna make it private?
Okay, do you want to make it private? Okay.
And
Why do you want to make it private?
so it's more
That should be a reason.
isn't that good practice? So someone can't change that.
Because count should not allow anyone to change, right?
Undeniable.
Like should not open to the public. It should encourage the encapsulation here. So when we add, you said you want to do incremented count. Okay, we put a count plus plus, right? Because you want to increment the count. And what's next? Are we done with the size?
And you need to do it for remove too. -1.
Return count, huh? For the size.
And then for like clear, you can do like count equals like null.
Okay, remove. You want to say count minus minus. Okay. We have to remove, right? Okay. Let's finish one. Okay, we will try to add. How do we implement is empty? Yeah, we have to finish is empty.
Size equals 0. Oh, like head and
Count
10
equals-
equals null.
Count equals count, yeah, count is count.
You said
Oh, never mind. Count is supposed to be negative.
Yeah, head and tail equals null because if there's nothing in there, it's gonna be no head, no tail,
right.
nothing in there. They get points.
If Toko no, then right. Okay, you get points.
I mean, there's more than one like way to make that write that method, right? There's plenty of ways to write that method. You do count equals 0 to that works.
Yeah.
I was thinking, why don't you just count is equal to negative?
Okay, now we get is empty already. Let's continue.
Head equals
We create a new node. Okay, when it's empty, we do this. Now, if it's not empty, that means we have this. What do? We create a new node.
Is it like temp?
Alright, who wants to write else statement? How many points do you want to bet?
Bet it all.
You already have one. But you already have one. You only have one. You cannot have more than what you have, right?
Bet 99.
Okay, so I cannot do it?
You
That's what you're saying?
no. You only have one. You can only bet one.
Oh.
Okay.
Can you double it? Like, can you like?
You have to gain and then you can bet more.
Fair, Professor.
So if it's not empty, then you don't have current, do you? 10.
That's a hot seat up there.
Set. We have a set? No. Oh, which one? No. Oh, you don't. Oh, we need to do no element. Next. We have next, right? We have so set next.
So what's the easiest way to do? Think about it first.
Head dot next.
Like when I do this, I normally have to draw the pictures. They can see what I need. So you create getter and setters
Yeah.
for next. Okay.
Then you have to create no temp ones. Or okay. Look before just look before. Okay. Why is temp is here? Why is red?
You know why?
Oh, because you have to
You
make
know
it.
the scope, right?
Yeah.
It's the scope, right?
And set next. Does it go to what was our head? Head dot get next. Oh, it's opposite.
So if you do head or get next,
It's gonna be
it's always going to insert after the head every time.
so this one is going to be get next head.
But where you want to insert, let's look at the image again. You want to insert at the end, right?
At the end? Okay, so
Every time you insert at the end, the list, right?
okay, so we're gonna say head dot next.
Now, aren't we sitting at the end? So would it be?
So are we
Right.
adding
Look
at
at
the beginning or
when you
the-
when you add, you already create a new node from line 16, which is this guy, right? What's the next step that we want to do?
shouldn't it be tail dot set next? So this is our head, right?
You want to you want to set this pointer to point to this new node, right?
So
And how to get to this pointer?
the temp dot set get. No,
1 second. What's temp? Temp
is
actually a new node. This guy is a temp,
down.
right? Because you said new node is temp.
Okay.
This guy actually, you see, if you draw it, you see this is actually a temp. It's not part of the list at all, right?
Okay. So
Whenever you create a new node,
head
this is a
dot
temp.
head dot set next is then bracket temp dot get next.
Now, if you do head dot set next, when it's 2 element, it's fine. But what happens if it's more than 2? You always insert after head every time. But you want to insert at the end, right? What do you do when you insert at the end? Look, I only have 2, right? If I add another element, you still linking head to that guy,
Okay, tail.
right? Right, so you have to do tail.set next, right? Correct? So what do you want to set to? Tail, remember we want to set to point to the temp. We want to set this to point to this guy, right? Set next, tail.set next to where? The temp. Because if you do temp.get next, it's
gonna
take the
be
null. Right? It's all, this is also wrong, right?
Okay. Alright, but I think.
Now let's look at the image. Now what he did, okay, let me get the eraser, no longer null, right? And it's pretty much just point to this guy now, right? If I get the selection tools, I think I can select this. Now it's pointing to this, correct? That's how you link. And this is still temp, okay? And this guy is going to be null. Sometimes we use slash, right? It's just pointing to null, the same thing. We just use slash at the end, okay? Is it done?
Oh, okay.
Is it done? No. Like you see, like I said, when you draw image, you know right away it's not done. What is wrong? What's missing?
Yeah, you have to move the tail to the temp.
Okay, how do you do that?
Tail is equal to temp.
Right, so that's how you pretty much technically now you move this guy, right? To this, right? Because it's pointing to the same location. So that's at least.
Yes, I got the point.
Really?
I did that right.
What do you think? Okay, I'm not the judge, right? Okay. Who's gonna be the judge? You guys gonna be the judge. He get the points, I know.
Yes. Collaborative effort.
There you go.
All should just
How?
One's for everyone.
Professor.
No, it's just the one who volunteer, right?
Professor.
Okay.
You should get a point.
All right.
Have to say anything else? Alright.
Now, is it done? How do you know it works? Like, if I create another node, okay? This is a new node. It's going to go to else right away, correct? And it's a tail.set next, which is going to point this guy, right? Tail.set next, right? Oops. To the temp, which is this guy, right? Because technically now temp is this guy, right? When you do that, right? And then it's going to say tail is equal to temp, then it's going to move this again. So it looks good so far, right? And no longer have the null, right? So it looks good so far, right? Now we have to do a unit test, right? So to do this, we have to be able to do what? 12 also? 12ers? You want to 12ers? To print out all the elements in the list, correct? So how do we do that? Pretty much your toString that we have to implement. So we're gonna write toString or iterator. So what is iterator? It's going to iterate to the list. So let's review the iterator for the list again. Last time we used an array. This is use array to create, right? So this is check. We're looking for remove. We're looking for set. This is toString, right? You can see that toString pretty much just go through the list and print all the contents, right? This is with array list. And the iterator pretty much just create a new iterator right there. One second. Yes. Yeah, can I call you back in 20 minutes? Okay, thanks. Bye. Thank you. Sorry. So this iterator, so we want to look at, now we understand toString pretty much just print all the contents, right? In your list. So what's the iterator for then? So when you implement iterators, this guy create a new array list iterator. And this is a class for the new array list. Iterator pretty much just going to have, if you look at the iterator interface here, it's going to require you to have three methods: has next, next, and remove. Okay. And has next pretty much is going to return, you see, current. If the current less than the size, that means yes, it's true, because you set your current to 0. It's pretty much just you create a pointer to point to the current location, and you move that pointer forward, right? If that pointer is still less than the size, that means it's true. You still have next, has next, has next. And then next, pretty much just move your data to the next location. That's next. You can move the pointer, right? By calling next. Remove, pretty much just remove data at your current location. Okay? So those are three things. That's what we need to look at. But now we want to look at toString first. But toString in the array list version, you just loop to the size, right? And append the result and print it out. We technically want to do the same, append the result, but we're going to ask that how do we iterate through the list when it's not array? This is an array way, right? But we want to iterate to the list like a linked list way. So it's going to return the contents in the list. So we're going to write toString. So can you tell me, should we use override? Why? It's override toString of the object, right? And why we want to do that? There you go. If you don't, it's going to print out the memory address. The one thing. Really? If you don't do override, is this going to print out the memory address?
Well, if you don't have a toString method.
Okay, if you don't have the toString method, correct, it's going to print out the the address memory. But if I have toString, do I need to do override? I mean, we talk about this one, right? What's the benefit of this word? Anybody know?
So it knows which one to use, depending on what class.
No. talk about dynamic binding, when you talk about that. Hmm?
To return all the never mind.
No one know, huh?
I know, I was never taught what that does.
That's why I'm going to teach you. And put that in your memory. Not in the RAM, okay? In hard disk. Otherwise, it's volatile. You don't need to have this if you don't care about your typo. You can say to string whatever. And then when you call, you just do dot. Make sure you do T or like caps to string. This one will never override the object to string because it's just like you create a new method. But what's the point of that, right? And when you do print out, you have to, when you do the instance only, you don't need to do dot to string. In this case, you have to do dot caps to string, right? Yeah. Okay, this whole thing is just making sure that you intention to overwrite. See that if you put it, it's going to complain. Does not overwrite. You sure you try to overwrite? Now you say, oh, because I typed wrong. So the point is just, it's going to make the compiler check that you are actually overwrite the parents, right? The method of the parent class, which is toString of the object. Now we gotta return the result, right? This is string builder. Can we make, how do we make string builder to toString? Right there, huh? So how do we iterate? And result is going to close with a bracket, right? Dot append. Alright, let's look at the list again. How do we iterate and get the elements from each node? You start with a loop. Okay, we have to initialize your current pointer to the head, right?
So while I is equal to 0 and I less than size
I.
I was going to say while is not equal.
We could use iterator if we implement iterator, but now we didn't implement iterator yet.
Do we have like a current?
while loop. So while has next not is equal to null, and you just add the string.
Okay.
Yeah, while has next is not equal null.
Do you want to implement iterator too? Because it looks like we were talking about has next, huh? You want to use that? Like we have has next, next, and we have current. Okay, let's see. We gonna say return what? New linked list iterator. Now we're going to implement the, we call inner class, where destination, let's create an inner class, private, right? Do we use private? Yeah, because it's only valid inside this class, right? Private class, you create class inside the class, right? In the class. And this class only used for this iterator inside the class. And this class going to what? Iterator. This class going to this one is going to be invalid until you do what? Polymorphisms to interface name iterator. Implements right. Identifier expected. This is an inner class. You could create inside and close inside.
Is it an iterator instead of iterable?
Iterator, right? Iterator.
Iterator. And you have iterable. Elements.
Oh,
Iterable.
you don't need the parentheses, right?
Oh, this is a class. Thank you. Implements the method. All right, so we have required it. Oh, I see you talk about this guy, right?
Yeah. Does it matter?
That's why the methods are different. Yes, it does matter, right? Because I want iterator, not iterable.
So shouldn't you change the main class as well? Because I think in the main class you have iterable as well.
Where?
Or does that not matter?
Where is it?
Oh, never mind.
Okay, now we have has next, next, and remove, right? Now, what we want is we want to implement has next, right? And we want to create a current, right? So how do you create a current? This guy current equal to 0 when it's array, but it's not an array. So private what? Current should be head, right? So it's like 0, right? Node current equals to head. Alright, so has next. How do you know it has next?
Objective card is current dot next equals null.
Is it? Let's think. Because if it's equal to tail, should not have next anymore, right?
So put an exclamation in parentheses. Return.
Why don't you just say, oh, okay.
So yeah, because this is gonna be if it has next.
Why can't you say current dot next if current dot next equals null, and
If current dot next is not equal null. Yeah.
Okay, you said current dot next. That's another way, right? Not equals to null. That's what you said, right?
Yeah.
That's what you want to say, right?
I think equal.
Ooh. I think you call get next, right?
Yeah.
That's what you call. I think it's technically the same thing, right? How about next? Pretty much current at get next, right? Remove. What's wrong with this guy? Get next. This has to return nodes, right? Do you want to return nodes? Or we want to return the elements? That's another question. If we want to return the elements, we have to do we actually want to return element, right? I think, correct? Then you have to implement what? The elements, right? It's like get element, right? So next mean you want to get next and then get the element of the node, right? Otherwise that means you return a node instead of return the element of the node, correct? Because get next return a node, right? And get element is the contents of that node.
What if next was
Then has next, right? So let's see if they're taking care of that in this guy always say current plus plus. Now what if is index outbound, right? So that means in your program you have to check first before you can next, right? Before you use, you have to say like linked list iterator has next. If has next is true, then you can do next. Yeah, you're gonna have errors. Yes. How about remove? Okay, let's check back later. Let's finish the toString and we come back to this. We don't need to remove for toString. We just want to print the contents, right? Alright, so how do we print the contents now? We already have the structure create for that. And we have iterators to use. And then we have current too. So technically we want to get the iterator then, right? To create new, then we get a current, right?
Have you ever changed current on the bottom? Move the current to the next one.
Oh, it has to be this guy, right? Yeah, next should change the current, you're right. Actually, next should also change the current, right? Yes. That's a good point. So how do we change the current? Pretty much just current what? Is that how you change the current? Then in that case we just do like that, right? Because we change the current, right? And then get the elements of the current. Is that right?
Yeah, but you might have an out of bounds. Current equals current dot get next.
But we want to check has next first, right?
Oh yeah.
So meaning, how do we implement that?
Initialize the iterator.
Okay. How do we initialize iterator? It's return iterator, right? So we gonna call it iterator. Iterator equals to like that. Initialize, huh? What's next?
Then check if ball has next.
If or while.
Or use a while since it's a loop.
right? Because we want to keep going, right? While iterator has next, right? While it has next, what do? We just appending it, right? By next is return elements, right? So result dot append and then iterator dot next, because return element that we append, right? Correct?
Shouldn't we introduce a toString method for the node and then call .next.toString? Or no? To see what the element is, rather than just like.
Oh, you mean like this? Like rather than append like that?
Sorry, what was that?
Introduce iterator.next.toString.
Well, like just a toString method within the node class. Otherwise, won't we just get like an address printed out instead of the element?
Oh, because this guy have current element. Right, when you do next, it's called this guy, right? And this guy already returned an element, right? Oh, I see what you mean. Like toString. Otherwise, it may return object E. Right? But yeah, it could be if this is an object, yes. But if it's not, right?
Sorry, does that really even matter though? Because like you said, it's returning an element, not the node.
Yeah, but if the element happen to be string, it's fine. It's still print string.
Yeah.
But the element happen to be object, then it's going to print the address. So that's why we should introduce toString, right? So if we introduce toString here, same thing, we overwrite, right? And then, but now technically, actually, we don't have to, because it depends on when you cast.
Yeah, the object should have to.
Yeah, when you cast, yeah, you don't really need to.
So for our next right there, I think we have an issue. I think we don't return the first one, right? We don't just,
This one?
yeah, no, for public E next, right there.
Mm-hmm.
Does that return the first one?
Oh, because we get next right away, huh? Then we want to append the first one first.
Should we just change the,
This next?
yeah, right? Or,
Should next do that? Like next should always,
okay.
right? That means so, meaning we gonna do result dot append the first one first, right? Append what? The first one should be,
That's what I was saying. It's probably easier if you don't use the iterator and you just say while the
be-
current null, then just do all that stuff.
you could do that way, like I said. Yeah, or we could do. Now, how do we append the first one? If we since we already do this.
Head dot get elements.
I was looking at here that German, you said. What happens if it's no? If the list is empty,
Then you add.
this is not gonna work, right?
If you do it the other way, like I was saying, then you don't really run into that problem, right?
So can we get current out? Nope. So it's always return next and the current, yeah. So meaning you might want to say if, right, height not equals to null, right? Then you do that, right? Alright, are we done yet? Has next is could keep appending while otherwise going to return false, exit. It should done, right? It should be done, correct? So I guess what we want to do, you technically want to do the test and see as and then call to string and see if it's thing we do at test, right? Normally it should show the test, right? L enter it should show the test, right?
So you do it inside, yeah. You can go to navigate and just hit test.
So now we could do the unit 4. What do you want to test? The add, right? And we technically, what do you want to do? Create a new list. How do you create a new list? Link it, list, and then let's just test with the string type, okay? A list equals to new, link it list. Now we start to do a list dot add, right? David. Who else you want to add? Mary. Let's add like 3 guys. John. Alright, so if the list is working, we should be able to call and print out a list. Should call the toString and do all the work, right? And print out the list, correct? If it works, then we can call a day. There you go. David, Mary, John. Alright, I think that should be it.